All right, so taking a look at creating some equations here. Okay, so we're going to talk about creating equations from a contextual story problem, a word problem. You've probably heard all those different names used for it. So the first thing we need to think about is what does it do that, well, let's start that over. What do we need to know in order to create an equation from a contextual problem? Okay. So there's two main pieces of information that we're looking for here, okay, when we do a story problem, okay, that will help us understand what's happening. And to think about this, think back when we were doing those dot problems, right? Did it a couple of them, but here's just one of them. And we had, so at the beginning, okay, we had after 1 minute, after 2 minutes, and so on, right? And we ended up making an equation which looked something like this. And here's just the expression part of it. Actually, we used t, didn't we? So 4 times t plus 1. And that was equal to the number of total dots, right, per minute. Okay, well, what was the information we needed there? Okay, well, we had this piece right here, right? And the t, the variable, that represented something different than the plus 1 and then the 4. Okay, so if we think about that again, so again, we looked at the beginning, okay, that was represented by that plus 1, wasn't it? Okay, then each arm received a dot every minute, didn't they? Okay, and there were 4 arms, which represents the 4, and then depending on how many minutes there were that many dots on each arm, right? So that's how it connected to the t. Okay, so essentially what did we need in order to do that? Well, we needed the start and we needed the growth. Okay, that plus 4 each time. Okay, so what are the two things we need? We need how it's going to start and then also how it is growing. Okay, if we have those two pieces of information, we'll be able to make an equation with that. Okay, so that's just like how when we had our other one, right, came up with that other one, which this one had the 3 dots and then it doubled, right? I'm not going to draw out the whole thing. So we had that other situation which was similar, where we had at the beginning, at the start, after 1 minute, after 2 minutes, and we kept going, and we found out that we were doubling as we went. And we ended up coming up with another equation for this one, which was the total number of dots was equal to, again, that start number, and then what are we doing to it? We're timesing it by 2 every time. And because we were doing repeated addition, we actually had our variable up at the top. Okay, just like this is repeated addition, this one was repeated multiplication. Okay, so it doesn't really matter what type of situation we have going on. It all again goes down to that idea of, do we know the start number and do we know how it's growing? If we have those two pieces of information, it's very easy to make an equation. Okay, so let's take a look at this. Let's look at this first example. So let's do a couple of examples, then we'll be able to do some and have you guys kind of try to work through it alone, go over it and that kind of stuff. Okay, so let's see. Let's grab something so we can follow along. So, first example, you create an app that records how many times you use social media. Backtracking your data, it found that you have already logged in 27 times in the past weekend. You check it a week later and find that you average 34 posts, messages, whichever one you're using, per day, in how many days will you have reached 1,013 post messages, okay? So this one actually wants this question, most of the time the question has us get to an answer, but the idea here is that we're going to first make an equation, then we can use that equation to answer, okay? So let's grab our pen. Let's actually get a different color for right now. Okay, so we got to figure out, where did we start? How is it growing? Now, those words per day, okay, those are a pretty good key, that per. It could be per day, per minute, per hour, per toenail, per, anything, okay? That's going to key you into your growth, okay? So that's our growth. So if that's our growth, then we say, okay, where did we start? Well, when we first logged in, we started with saying that we'd done it 27 times in the past weekend, okay? So our start number is 27, and our growth is 34 posts per day, okay? So to make our equation, okay, basically we want to know in how many days. So days would be our variable, right? We'll use D for that. And the result is how many posts or messages, right? We'll say P maybe for posts. Okay. So we want to know posts, and that is equal to, and we started with 27. So here's where we're making the equation, okay? So we start with 27, and this is kind of the way to think about it, okay? So we had the weekend, started with 27, okay? Then it says we're averaging 34 posts per day. So Monday rolls around, and how many posts did we do? Well, 34. Then Tuesday rolled around, how many more? We did 34 more. And Wednesday, and so forth, right? So every day we're tacking on 34 more posts. So we started with 27, and now we're going to add 34. Now how many times are we going to add 34? Well, we're going to go till we get to however many days it takes us to post this many, right? 1,013. So that would be our days. However many days times 34 is going to equal 27, okay? So there's our equation. Now, if we want to answer the question and get to 1,013, we're going to kind of have to think backwards, okay? We are thinking, and what am I doing? This is a new program for me, so sorry about that. I'm actually not using the program to record, I'm using the iPad to record, so just kind of screencasting. But anyway, so we've got 1,013, right? That we're doing here, okay? And that's the number of posts, and we want to know how many days it'll take us to get to 34, okay? Well, if we think about this, first thing we got to do is subtract 27 of them, right? Okay? Because those were the ones that are on without a day. So we go 1,013, and we can use a calculator if we need to, subtract 27. So we have 986 posts. And that would be represented by this, right? That 34 per day. So we need to know how many days, so we do the opposite of multiplication. So we're going to divide. So 986 divided by 34 gives us 29. So almost a month, 29 days, we'd have that many posts. But again, the focus here was more right here on our equation, okay? So there we go. All right, let's move things up, right? Okay, let's look at another example. So Albertimus is looking into adding to his Unicorn Patrol collection. He currently has the original 5, but since the show has ran through many different Unicorn Patrol members, he's looking to collect them all. With his allowance, he figures that he can buy one every 2 years. How many years until he has all 14 of them, okay? So again, we want to start with an equation. So again, we're looking at growth and starting. Okay, so he currently has the original 5. Well, that's going to be our start, isn't it? And he says with his allowance, he can buy one every 2 years. Okay, so that would be our growth, wouldn't it? So 1 is our growth. but it's every 2 years. Okay, so depending on how you structure it, you could think of it like 1 every 2 years, or because generally we don't like to do something every 2 years, we'd say, what does that mean every year? Well, that means he would buy half of 1 every year, wouldn't he? Okay. So, we're dealing with years, so we want to know how many years until he has all of them. So, his unicorn patrol, to get all of them, okay, what's it going to equal? Well, we start with 5, so we start with our 5, and then what are we doing? Well, every 2 years we're buying 1, but every year we've basically bought 1/2 of 1. So we're adding 1/2 every year, so we'll do a y for year. Okay, so 5 plus 1/2 y, there's our equation, and then we could use that to solve. Okay, so if we want to know how many years until he gets all of them, well, there's 14 total. He's already got the 5, right? So we'd subtract the 5 from that, giving us 9. Okay, so every 2 years he can buy 1. He needs to get 9. So basically we would double that, wouldn't we? And that would give us 18 years. Okay? But again, focus on once we have our start and our growth, we can easily make an equation with that. Okay? All right. Moving on through. Okay. So the average person spends about $120 eating fast food per month. In how many months will the average person spend 2,400? Okay. So again, we want to know where we start and how it grows. Okay. That's what we're looking for here, where it starts and how it grows. Well, they say they spend about $120 eating fast food per month. So that's our growth, right? $120 per month. But it doesn't tell us where we start, does it? Well, if you think about it, it kind of does. It hasn't said how much we've already spent, so we haven't spent any money. So for our equation, we're starting at 0. We're adding 120 every month, so we'll use m for month. And that's going to equal, in this case, 2,400, right? That's what we want to come up with. Okay? So there's an equation that would work for us. We could turn 2,400 into a variable if we wanted to. Okay? Adding 0 doesn't do anything, so basically we've got 120 months per month to get to 240. So we can get rid of those zeros just like that. And we should end up with what? 20? Yep. So in 20 months, almost a year, which is it's a lot of money if you think about it, just eating out, when there's cheaper ways to do that. Okay, but again, start and growth to get our equation. Okay? All right. Let's see. So should we do one more example together, and then we can have you try to work on some on your own? Okay. So Ethelbert is saving up for college. He currently has $400 and is making an additional $30 each week at his new job. How many weeks, months, or years until he will have enough saved up to attend UVU? Okay. So again, what are we looking for? That start and how it's growing. Okay. So he's saving up for college. So it says he currently has $400 and is making an additional $30 each week at his new job. Okay. So each week, that's kind of like every week, he has $30 more he's earned. And we're assuming that he's saving it all. Okay. Because it doesn't tell us otherwise. So his growth, his bank account growth, savings account, is $30 each week. So $30 per week. Okay, and how much does he already have? Well, he's starting already with $400, right? So we're starting with $400. So we start with that $400, okay, and what are we doing? We're adding 30 each week, W for week, and that will get, hopefully, enough money to attend UVU. Now, how much does it cost to attend UVU? Well, we'd have to look that up, and we can solve that, but we're not really concerned with that. We're just concerned with that equation, okay? That's all right, we're really worried about right now, okay? But we could look that up and try to figure it out if we really wanted to. Okay? All right, so here's this one. So for this plan, let's see, I'm going to leave it down here so you don't get distracted by the other one. Okay, let's, so if we could have Mr. Vorwaller, or if you have a guest teacher in here instead, they could pause it right now. Well, not right this second, but let's do this. Let's give you 4 minutes, roughly. Okay, so what we're going to do is you're going to try this one on your own. I'll read it first, and as soon as I'm done reading it, you can have the guest teacher or Mr. Vorwaller pause it. Give you about 4 minutes. I want you guys to try this one on your own. If you need a little bit more time, that's great. They can keep it paused for a little bit longer. Then after, we'll talk through it, okay? So I'm going to read through it, and then we are going to give you guys 4 minutes. So, oh, sorry, wrong thing. There we go. So Horatio's mom is tired of his toenail clippings being stored in the basement. They estimate that he currently has 270 pounds of toenails, not of them all over his own, in the basement. His mom wants 15 pounds removed every day. How many days will it take to get rid of all of the toenails? All right, you guys try that one. Guest teacher, Mr. Vorwaller, pause it now. All right, so they should have paused it. You should all have an answer here to go with. Okay, so let's jump into it. If you haven't paused it yet, hurry and pause it. But if not, here we go. So we need to know the start number. We need to know the growth. Okay, so hopefully you realize that he currently has 270 pounds of toenails. Would be our starting number. And then his mom says he's got to remove 15 pounds every day. Okay, so we're removing 15. Now, because we're taking it away, now we'll talk about that. So let's make our equation. So we start out with 270. And what does mom want that to do? She wants it to go down. She wants him to remove, so we'd be subtracting 15 pounds every day, wouldn't we? And since it's every day, we can use D for day, or X, or Y, or whatever letter you would like to. Okay? And what do we want that to equal? Well, to get rid of all the toenails would bring it down to 0, wouldn't it? Okay, now you could have put an equation here in 0, or a variable here in 0 instead, or you can leave it like that to solve. So let's figure this out. So what are we going to do here? Okay, well, we figure we've got the 270, right? Okay, and if we're there's two ways we can solve this, I guess I should say. Let me erase that. Okay, there's really two ways to think through this problem. One way is mathematically, which I would say I'm going to add 15d to both sides because I like dealing with positives. That becomes 0, so I get 270 equals 15d. Divide by 15, and I get d equals, and I don't know 270 divided by 15 in my head, so I'm going to grab a calculator. 270 divided by 15 equals 18. So it would take 18 days. That's one way I can think about it. Or I really could just go 270 and subtract 15 till I get to 0, couldn't I? Or I could think of it this way. Well, I'm taking 15 pounds per day, so I'd go 270 divided by 15, which is what we did here, and that would get me 18. Okay, I could just kind of think through it as well. So, how did you guys do? Hopefully you did pretty well and managed to get those done pretty good, okay? So, let's take a look at some more problems, okay? So, let's not worry about that one. It's kind of big. Let's look at these two. Okay. Actually, that one with James is, we'll talk about that one together. So let's look at this one right here. Brianna, okay? So we're going to kind of do the same thing and give ourselves some time. So, Brianna has saved $600 to buy a new TV. If the TV she wants costs $1,800 and she saves $20 a week, how many years will it take her to buy the TV? Okay? So again, I want you to come up with an equation and then solve it. So let's pause it again for another about 4 to 5 minutes, unless you need more time. So pause it now. All right, so you should have worked on this one on your own. Let's see how you did. So we should have noticed and realized that she already has saved $600. So there's our start. Okay. That the TV costs $1,800. That's our goal. And 20 a week is our growth. Okay. So our equation, she's got 600. Every week we're adding 20, so it's 20 times the weeks, and we want to get to that point where we have enough for that. So there's our equation. Hopefully you got something similar to this if you wrote it in different order, as long as all the pieces are the same. Now, 2 ways again we can think about this. The first way is to think in terms of just working through it step by step. Okay? And so we would be thinking we've got 1,800, and we'd subtract 600 from that to begin with, right? Giving us 1,200. So, like I said, I had to pause the video while somebody came in and vacuumed the room, so got a little distracted. So we took 1,800 and subtracted 600 from it, which, if we were solving the equation in the super mathematical way, same step, right? Because we're trying to get the W by itself. Okay? Then you'd realize, okay, so we've got this much left that we're going to have to use our growth for, so I would just divide it, wouldn't I? By 20. As we can see, that would be the same step we do here. Okay? So we'd end up with 60 weeks, regardless of which, if we kind of did it more in our head or if we did it in that more formal style. Okay? So, what do we think? Not too bad? Okay. Let's just do one more example for this last one for you guys. Okay? Let me clear some space here. And I wonder if I can make a shape go over that. And that is the shape of an arrow. There we go. There we go. All right. Okay, so it says James earns $15 per hour as a teller at a bank. In 1 week, he pays 17% of his earnings in state and federal taxes. His take-home pay for the week is $460.65. How many hours did James work? Okay, so this one's a little different, isn't it? Okay, so we know that he earns 15 per hour, don't we? Okay. That would be like our growth, wouldn't it? But in this case, well, we know his take-home pay was $460.65. Okay, that's kind of like the starting, but not quite the same. Okay, so there are some situations where just the growth and the start isn't exactly what you need, and you kind of have to think your way through it. But those are the main ones to think about, right? We also know that he's paying, 17% of his earnings in state and federal taxes, okay? So to get his total take-home, we would take the $460.65 and we'd add that 17% to it, wouldn't we? Okay? And that would tell us, how much he earned getting paid $16 an hour. Okay? Like that. Okay, so that's kind of a basic, but we can't just leave this 17% just like this. We've got to put it into some sort of monetary way, okay? So a good way to think about it is that 15 hours represents his total amount. That's kind of like his start, okay? And that's one way we could phrase it. So that 15H would represent his total amount that he earned. Then we'd subtract the 17% of that. Okay? Well, remember, when we deal with percents, mathematically, we take that decimal and we move it 2 places to the left. So we're talking about 0.17 of that $15 times H. Okay? And that's going to equal the 460.65. So this one's a little bit more complex. Now we can multiply that, kind of that order of operation stuff we've been dealing with. We can go 0.17 times 15, and that would be $2.55. So basically, the amount he makes per hour, he subtracts $2.55 to go to his taxes. Okay? Which we could simplify that even further and just go 15 minus that, right? 15 minus the 255, and we'd say he brings home, or what he earns, his take-home pay, is $12.45 times the number of hours he gets. And then we could, either any of these equations really work, and even this one in a sense does if we simplify that. Okay, so to solve this, we'd divide by 12.45, giving us H equals whatever 460.65 divided by 12.45 is, which ends up being 37. Okay? All right, there we go, guys. So, yeah, you should have some worksheets to work on to kind of help take a look at and make equations and even use those equations to solve stuff, okay? All right, there we go.